We have already came across different questions where we have to find number of squares in a chessboard. So a chessboard is a matrix grid where we have eight number of rows and 8 number of columns. So in such a case we have to find number of squares that can be formed of different sizes in this grid. So how do we solve these type of questions? So in this tutorial we will be learning about all the different methods to find squares and cubes in different grids, different cubes and cuboids. First, number of square in m into m square grid. This means that number of row is equal to number of column, and we have to find number of squares possible. For example, let us take a 4 into 4 grid. So we have to find number of squares. What are the different number of squares of 1 into 1 depth? Let us assume that all these are perfect squares of 1 into 1. So the row is of 4 centimeters or 4 unit and column is also 4 unit. So number of squares of 1 into 1, such type of squares. So we know there are 16 such squares, 4 multiplied by 4. So altogether we have 16 number of squares. What is the possible number of squares of 2 into 2? 2 into 2 squares means squares like this. First we will see along the row and then we will see along the column. 2 into 2. After that, the second square of 2 into 2 type will be this. And third one will be this. So we can see there are 3 squares in a row multiplied by 3 squares in column as well. So there will be total of 9 squares of 2 into 2 dimension. Similarly, 3 into 3 squares. One such square is this. After that, shifting to the nearest possible square, second square will be this. So there are 2 such squares, 2 in row and 2 in column. So total 4 squares are there. Now square of 4 into 4 type. 4 into 4 type, only one square is possible. So total number of squares will become 16 plus 9 plus 4 plus 1, that comes out to be 30. So total number of squares that is possible is 30. But what happens if we have a bigger grid? Let's take a grid like 8 into 8. Is there a generalized formula for this? So when we have m into m grid, m is 4 over here. So 16 can be written as m square. N can be written as m minus 1 whole square. 4 can be written as 4 minus 2 ka whole square. That means m minus 2 whole square. 1 can be written as m minus 3 whole square. So formula for these type of questions can be 1 square plus 2 square plus 3 square till m square. So if we had to find number of squares into 8 into 8 grid, then what we will do? Value of m will become 8. So 1 square plus 2 square plus 3 square till 8 square will be equal to. So what is the generalized formula for this is equal to m plus 1 2m plus 1 divided by 6. So value of m is 8 over here. 8 plus 1 is 9. 2m plus 1, 2 into 8 plus 1 is 17 divided by 6. This comes out to be 204. So this is our answer. Number of squares in a 8 into 8 square grid or chessboard is equal to 204. So the direct formula will be, if we have m into m square grid, what we'll do? We'll directly put this in this formula. 1 square plus 2 square plus 3 square plus m square. Putting in this formula, we'll get total number of squares that will be there in m into m grid. Now, number of squares in m into n grid. What are the total number of squares into m into n grid? M into n grid is one such grid where number of rows are 5 and number of columns are 4. So this is m into n grid. How do we solve such grids? Again we'll check number of squares of type 1 into 1. So 1 into 1 squares are these smaller squares. 1, 2, 3, 4, 5. 5 squares in a row. Number of squares in column are 1, 2, 3, 4. So 4 into 5, total number of squares are 20. Now 2 into 2 squares. 2 into 2 squares are such sort of squares. How many squares are there in a row? This was one square. After then, the second square will be something like this. Third square will be this area. Then again, fourth square will be. So number of squares in row here are 4. Number of squares in the column will become 3. 1, 2, 3. So this is 4 into 3, which again gives us a value of 12. Number of squares of kind 3 into 3. So what basically we can see here, that it forms a pattern. 1 less in this value, 1 less in this value. Again 1 less in this value is 3, 1 less in this value is 2. So kind of 3 into 3 squares will be 6. You can check it from here. 1, 2, 3, 4, 5, 6. 4 into 4 square will be 3 minus 1 is 2, 2 minus 1 is 1, 2. Is there 5 into 5 kind of square possible? No. 5 into 5 kind of square is not possible because the length of the column here is 4. So total number of squares will become 20 plus 12 plus 6 plus 2, which gives out a value of 40. So total number of squares over here are 40. What can be the generalized formula for these kind of questions? We know the grid was of m into n kind. Minus 1 from m, minus 1 from n will give us a number of squares of 2 into 2 kind. So 1 minus this is minus 1 into n minus 1. Following the similar pattern, m minus 2, n minus 2 and so on. So the generalized formula can be mn plus m minus 1, n minus 1 plus m minus 2, n minus 2 till where it will go? Till the point where any one out of m or n becomes 1, which means we'll continue this till a point where m or n, any one of it, becomes 1. For example, if we have to calculate number of squares of m into n kind using this formula, what we'll do, value of m is 5, n is 4, plus 5 minus 1 is 4, 4 minus 1 is 3, 5 minus 2, 3, 5 minus 2, 4 minus 2, 2, plus m minus 3 will become 2, n minus 3 will become 1. So now any one out of them becomes 1. Any one out of the terms becoming 1. This is the point where we have to stop. Adding all these, again 40 are the total number of squares that can be formed into m into n kind of grid. These type of questions basically come in quantitative aptitude, or they can either come in LR questions as well. So moving on, these are the number of squares that we are talking about. So what if there is a question where we have to calculate number of rectangles out of m into n? So for questions like number of rectangles in m into m grid, now we have a square grid, something like this. And we have to find number of rectangles over here. So how do we find it? See, number of points on row in different columns are first point, second point, third point, fourth point, fifth point. Similarly, number of points in column will become 1, 2, 3, 4, 5. Now to form any rectangle, we need minimum of 2 points. So let's say we have either these 2 points over here, this point and this point, and here we have these 2 points, let's say this point and this point. So drawing a line on these points, and similarly drawing a line on this point, we come across a region where our rectangle becomes this. Here rectangle includes all the square as well. So if we would have considered other point, let's say this was our grid. So suppose we have considered these 2 points over here and these 2 points over here. So using this line on y-axis, let's say we use these 2 points and we have this area. Using these 2 points, we again have this area. So this is the possible area of our rectangle over here. So to form any rectangle, all we need is 2 points from x-axis, 2 points from y-axis. We are using the concept of permutation and combination. So if we have to select 2 points out of n, the formula becomes NC2. What is this? When number of ways, NC2 is number of ways of selecting 2 points out of n. If we have n points and we have to select 2 points, NC2 is the number of ways of doing it. So let's come back to this case where we had 5 points over here, we had 5 points over here. So number of ways of selecting 2 points out of 5 points becomes 5C2. On a similar basis, number of ways of selecting 2 points out of 5 points is again 5c2. We'll multiply both of them. We selecting 2 points from here, and what we do, we select 2 points from x-axis and we select 2 points from y-axis. Number of ways of selecting 2 points from x-axis becomes 5c2. Number of ways of selecting 2 points from y-axis becomes 5c2. The sign for AND in permutation and combination is multiplication. So 5c2 into 5c2. Now what is the formula for NC2 or NCR? Formula for NCR is factorial N divided by factorial R into N minus R factorial. So calculating 5c2 is 5 factorial divided by 2 factorial. 5 minus 2 factorial is 3 factorial. 5 factorial can be written as 5 into 4 into 3 into 2 into 1. 2 factorial can be written as 2 into 1. 3 factorial can be written as 3 into 2 into 1. Value comes out to be 10. So putting this value over here, 10 into 10, we get a value 100, which means total number of rectangles in 4 into 4 grid. Number of rectangles in 4 into 4 grid is 100. So what happens when we have a m into n kind of grid? Number of rectangles in m into n grid. So if we have m into n grid, a grid like this, value of m becomes 4 here because we have 4 rows over here. We have 3 columns over here. So how many number of rectangles are there? What we do, we see the number of points. First step is we see the number of points. 1 point, 2 points, 3 points, 4 points. Out of 4 points, we have to select 2 points. Here also we have 1, 2, 3, 4, 5. We have 5 points. And out of 5, we have to select 2 points. Finding the value of 4c2 and 5c2. 4c2 becomes 4 factorial divided by 2 factorial. 4 minus 2 is again 2 factorial. This comes out to be 6. 5c2 we have already seen, the value is 10. So 6 into 10 gives us a value of 60. So total number of rectangles possible here are 60. In geometry we will be learning that all the squares are rectangle, but not all rectangles are square. What does this mean? This means that this is rectangle. This is not a square. This is rectangle, this is not a square. But what about this figure? This is a square and this is rectangle as well because it satisfies all the properties of rectangle. So in this type of grids, we have calculated the number of rectangles in it. But let us say we have a different question, a question like this. We are given with a grid of, let's say, 4 into 3. We have given a 4 into 3 grid and we have to find total rectangles which are not square. So what we'll do? We'll find total number of rectangles here. Total rectangles are 1.2345 out of 5, 2, out of 4 points, 2. This gives us 60. How can we find total number of squares in it? We already know the method, 1 square. Okay, say m into n grid. So m into n grid is m into n plus m minus 1 into n minus 1 and so on. So this will be 4 into 3, then reducing 1 from both these values. 3 into 2 plus 2 into 1. As soon as we get 1, we will stop. 12 plus 6 plus 2. This comes out to be 20. So in 4 into 3 grid, we have 60 rectangles, out of which we have 20 squares. So total rectangle which are not square will be 60 minus 20, that comes out to be 40. So these were the 4 tricks or 4 different methods of finding the total number of rectangles as well as total number of squares in m into n or m into m grid. Thank you.